name's Arthur Prochazka, and I'm at the Centre for Neuroscience at the University of Alberta. I'm a biomedical engineer by training and physiologist. We're mainly focused on trying to restore hand function or improve hand function in people who have paralyzed hands due to either spinal cord injury or stroke. And we do this by a combination of using electrical stimulation, which is voluntarily controlled by the person, currently using tooth clicks. So they wear a small sensor, a little bit like a hearing aid, and that picks up tiny vibrations in this little cartilage here. And when you make a tooth click, there's a bit of resonance in your head, and then we pick that up. That then activates a radio signal that goes down to a stimulator on the forearm, and then that opens or closes the hand. And we use that in combination with in-home tele-rehabilitation. We are the first group to have put together a system that works in people's homes, and we can access them, we can see them, of course, a bit like Skype. You can see people, talk to them, but we can also control the games that they play, because they're playing computer games on a type of joystick that we came up with called the ReJoyce. So in the process of playing the games, they're performing all sorts of hand movements that we've carefully designed and incorporate into the games. And these are hand movements that are used in activities of daily life. The ReJoyce system itself, I suppose we started work with some false starts, not with a joystick, but with other things, probably about eight or 9 years ago. And then the idea for the joystick approach, that was about 4 years ago, I think. And then, of course, it's quite complicated to set up a manufacturing facility. Of course, the clinical trials had to happen. But the manufacturing facility, getting the EC mark, for example, the regulatory process is complicated and costly. So it's been a very interesting and I'd say difficult road, but it's very rewarding as well. One of the aspects of the company, one of the activities, is to provide online demonstrations where clinicians anywhere can actually control a ReJoyce that is in Edmonton in the company's facility. And they can be trained in how to change the difficulty of the games, for example, and how to tele-supervise someone in their home environment. As well as, of course, we're about to release a new version of the hand stimulator device as well. Well, the ReJoyce system has now been commercialized. We have a facility in Edmonton that assembles the devices. They're quite complex devices, actually. Also, we've developed all the software through a company in Edmonton, and that company now has a distribution network in various countries, including in Southeast Asia and China. And so this year is really the year where the whole thing has moved from the lab and from institutes basically out into the world. We actually have improved people's hand function by a clinically significant amount. And I think if some of the drug companies and what are called biologics, the people doing stem cell transplants and so on, if they could achieve the same amount of improvement, they'd be delighted. And so that is perhaps the main message, that there are actually ways of helping people with spinal cord injury that don't have to be really super fancy from a sort of biological point of view, but build on the innate ability of the central nervous system to adapt to damage. But it has to be done in a very systematic and focused way, understanding what's required.